Today we are going to learn how to draw these elements. The goal of this is to draw elements so that when we learn about stars, it makes more sense when we're talking about these different specific elements and why they form in a specific order. Okay, so a reminder, protons have a positive charge, so when we draw that, it's simply a circle to represent the proton and then the positive to show its charge. A neutron is another particle, right? Subatomic particle with no charge, so it's a neutral charge. We leave it blank. It doesn't choose sides. But remember, protons and neutrons are in the nucleus, while electrons, the negative charge, are in the electron shells. So these are shells, and the magic rule is 2-8, meaning that the first shell can hold 2 electrons max, and then the next shell can hold 8 electrons max. But the point is that, like, let's say an element has 5 electrons. The first shell will have 2 electrons, and then we have 3 electrons left over to add up to 5, right? So that means that second shell, it doesn't always have to have 8 in it, right? It can have from 1 to 8 in them, but it can't have more than 8. So these are just basic rules of chemistry. So here's how we draw the elements. First, we go to the periodic table, and we determine the amount of protons using the atomic number, like we've done. After that, we determine the amount of electrons. So in our case, right, not always in reality, but in our case, the protons will balance the electrons. And that's normally the case. That's normally what happens in the real world. But there's other things called ions, which there's not a balance. So keep that in mind. Then you're going to go to the atomic weight, right, to determine the amount of neutrons. So just a reminder, the atomic weight's at the bottom of the periodic table of elements, like the particular element, it's at the bottom, and we just subtract the weight, we subtract the atomic number from the atomic weight, right, to find the amount of neutrons. Then when we draw it, we need to draw the atomic weight as the nucleus, meaning the protons and the neutrons. So if your atomic weight is 12, you better have 12 circles drawn in the middle. And then depending on the amount of protons, some will be positive, some will be left blank as neutrons. Then we need to draw a ring around the atom and place up to 2 electrons on that. And if there are more than 2 electrons in that element, then we go to a second ring where we place up to 8 electrons. And then just so you know, the following ring can hold up to 18 electrons. Now, to be clear, this is a watered down version of chemistry. The way that we're doing this is not always the way that you're going to do this if you go to college and pursue a science degree and take a chemistry class. But this is the basics. These are the basic steps. These are the basic ideas. So if you keep this stuff in mind when you're in chemistry in an upper level course, this stuff will guide you, but these aren't strict rules. The 2-8 rule is pretty strict, but depending on they're called valence electrons, depending on these huge elements, it can get more complicated. That's my main point. So let's draw this together. Helium, right? We got to find out the amount of protons it has. So first step is it has 2 protons because its atomic number is 2, and that's what makes it helium. Then the electrons are going to balance, which will have 2 electrons, so we'll only be needing 1 shell. After that, we need to find out the amount of neutrons. So in this case, 4.03. I'm going to say that's closer to 4, so I'll stick with 4 on that. So if we want to find out the amount of neutrons, we just go 4 minus 2. So this is going to be 2 neutrons. And since we have an atomic weight of 4, that means we need to have 4 things in the center of our atom, its nucleus. So that's 2 protons, 2 neutrons. And that's what we'll draw. And then we'll draw the ring, or rings, right? In this case, we're only going to need 1 ring. And we're going to remember the 2-8 rule. The first shell can hold 2 electrons. The second shell can hold up to 8 electrons. So let's draw this out. Let me show you on the board. Okay. So I do suggest, at least in the beginning, or really you should always do this. So the protons we determined, because the atomic number is 2. The neutrons, the next step is the electrons. The electrons balance in our case, and not always, remember, it's not always going to be a balance because we have ions in the world, which are just charged particles, right? So the electron is going to be 2. And then in our case, the neutrons, we're going to subtract the atomic number, which is 2, from the atomic weight, which is going to give us 2. So that's nice and easy. We start with our nucleus. Our nucleus, it comes from the atomic weight, which is 4. I need to draw 4 circles side by side. 3, 4. I like to keep it balanced. So like, if this is a proton's not going to want to be right next to another proton. So I'll put another one across from it to kind of keep them balanced out. There's rules to this when you get to upper level chemistry, but for now we'll just kind of keep things balanced out. In our case, we have 2 protons, 2 neutrons. Check, check. 2 protons, 2 neutrons. We're going to draw our first shell here, right? And these are electrons. So draw a circle, a minus sign, and then again we like to keep things balanced, so it'll be across from it. And those are our electrons. This is a helium element. Basic helium, nothing complex about it, right? You've got 2 protons, 2 neutrons, 2 electrons, and it only uses 1 shell. So the fact that this shell is completely filled up has partially something to do with the reason why it is a noble gas. Helium doesn't like bonding with other things. Helium wants to be alone. It's a solo runner. Because its electron shell is completely filled. Okay? So let us try this one. So try this one on your own. You may want to just draw it down somewhere and then check your answer. So pause the video if you need, and then check your answer. Okay, so let me give you the answer to this. I'm going to turn it so we can go through this. All right. So this is a nitrogen, right? So humans, when we breathe, 78% of the air that we breathe in is nitrogen. So this stuff's pretty important to us, okay? So let's get this going. So I'll just draw the element here. Nitrogen, which has an atomic number of 7 and an atomic weight of 14.007. Okay? So we start with protons. Protons. The amount of protons is going to be 7 because that's what our atomic number is. The neutrons, believe me, you may not want to do this math, but once we get into more complicated stuff, you're going to be grateful that you know the math aspect of it. So the neutrons, of course, are 7, and the electrons balance the amount of protons, for our sake, 7. All right? So this number, once again, is the amount of circles we need to have in our nucleus. It's the protons and neutrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 7 of them will be protons. I'm just going to go every other one so that they're not too close to each other. 1, 2, 3, 4, 5, 6. Oh, sorry. 1, 2, 3, 4, 5, 6, 7. So I'm going to erase this one. Okay. So there's our nucleus. Now, our first electron shell can only hold 2 electrons. Woo! 2 electrons. Right? Now, our next electron shell can hold 8 electrons. So we've already used 2. So we've used 2 of these. So I need to have, 7 minus 2, 5 electrons left. So I'm going to draw another shell around it, and I'm going to put 5 electrons on this one. 1, 2, 3, 4, and 5. 5. Okay. So there it is. That's the basics of Bohr's model. This is Bohr's model right here, and that's going to be our little basics. Okay. So let's talk a little bit more. Actually, you know what? We'll stop this, and I'll introduce this idea. So I'm going to have you pick an element between 3 and 13. 3 and 18, and you're going to draw it right after this. Also, there's going to be another assignment after this where we're going to make up our own element. So I will be sharing this with you. This is going to be an assignment. You're going to just create an element. It should make sense in the sense of that, like, the amount of protons and neutrons are very similar or close, but if you choose an element with a high number, like anything above, let's say like 25, if you choose an element with more than 25 protons in it, then you are going to need to have a few more than 25 neutrons to keep it stable. Remember, when we have a lot of protons in an element, we need many more neutrons to keep those protons calm and stable, okay? So you're also going to draw a Bohr's model on it, so make sure you don't choose like 100 protons and like 150 neutrons, because then you're going to be drawing 250 circles, which is going to be absurd. Okay? So start with this. It's going to be in the Nearpod right after this. Pick an element, 3 through 18, and draw it. Other than nitrogen, because we already did that.